I got another circle fact for you today to add on to the rest. Before we do that, up on the board, I have two types of angles that you should be familiar with. All right, two angles inside a circle that you should be familiar with. I'm going to introduce a third one today, but I want to make sure we are good on the two that I have up on the board. All right, so angle B, I'll let you know B is the center. All right, B is the center of that circle. So what is the name for angle B up here? That is a what type of angle in the circle? Let's start us off here, right? Let's go. Ian, what do you got? A centered angle. Like it's off to the side, but now it's centered.
Central.
Yeah, there we go. Back to big redemption. That's a central angle. Good. And what's the rule? How do I find a central angle? Angle B. Any central angle I should know the rule for. How do I find it? Let's talk to Charlie. How do I find it?
It's like the half of the arc.
Not half. It is the arc. It is the arc. So this would be the measure of arc, CA. Okay. Good so far? What type of angle is this one up here? Angle F. The other one you should know. Angle F is what type of angle in the circle here? Let's go, Gabby. Inscribed. Good work. Now, how do I find an inscribed angle? Can be found. Amy? Yep, half of the arc it's drawn to, which is EG. All right, so these are the only two you know of inside a circle. I'm going to introduce a third and final one right now, inside a circle. All right, so look at your diagram that I've given you at the top of today's notes. I could actually pick any four of these angles right here, just to let you know they're all the same type. I'm going to focus on angle ACB. I just picked one of the four up there. All right, ACB. Can we please all agree first? Is that a central angle? No. Is that an inscribed? No. So it's a new one we're not familiar with until right now. Here's the name I give to it. Not very mathematical. I'm not even going to take credit for it because I stole it from a teacher years ago. I call these angles floater angles. Floater angles. Why do I call them floater angles? Because they're just kind of they're not attached to anything. They're just kind of floating inside the circle. Good? Floater angles. What's up, Josh?
Did we get interview Wednesday?
No, not everyone did the homework. Sorry. Okay. Sorry. I remembered this time. Floater angle. Oh, good. All right. So today's topic, how do you find a floater angle? Because we know inscribed, it's equal to half its arc. Central angle, it's equal to its arc. We're machines in here. We know everything. Floater angle, here it is. And I'm sorry it's lengthy. All right. The description is lengthy on how to find a floater angle. First thing, you find the measure of its connected arc. So its connected arc. We know it's got to be more than that because that would be a central angle then. So its connected arc plus we add in, ready for this one? Its vertical angles connected arc. Sorry, it's lengthy. I'm not sorry. Who am I kidding? There's still more. And we take both arcs, add them together, and cut it in half. Divided by 2. So that's how you find a floater. You take the arc it's connected to, add it to its vertical angles connected arc, and we divide those by 2. All right, floater angle. The final angle inside a circle. Final angle. We good? Thomas, you need help taking notes today? You good with notes? Okay, just checking. All right, here we go. Number 1. I'm going to tell you that is not a central angle. That is not a central angle. All right, everyone good? That's not a central angle. I'm not going to make this easy and say it's equal to 88. It is a floater angle. So here's how we find it. Floater angle. What arc is connected to floater angle X? What arc is connected to it? What's its measure? Charlie. 88. So I take that 88, add it to its vertical angles connected arc, which would be Amy?
86.
86. Divide that by 2. Honors kids. Why are we picking up a calculator for this? If you got an 88 on an exam and an 86 on the second one, I want to know what your average is right between it. Oh, yeah, that's how the numbers work. Oh, I get it. That's pretty cool. Yeah, 87 degrees. Some of you guys won't figure that out until 8th period, what we just talked about, but it's fine. Okay, oh, it's right in the middle. Okay. Oh, good. Sometimes I'll give you the floater and ask for the arc in return instead. So everyone sees 65, floater, not central, not inscribed, definite floater. So I say now 65 equals, the floater angle equals, name the arc it's connected to. Oh, Amy again, name the arc it's connected to. 100. First time that number's on some of your papers all year, huh? Whoa, coming strong today here. Coming strong. Good, some of you will get that joke 8th period too. Yep. Along with what's its vertical angles connected arc. What's its vertical angles arc? Let's go deep here. Ooh, deep, Zeef. The vertical floater angle is 65. It's vertical. It's 60. What arc is it connected to? That's what I'm asking. There you go. Yep. And now I divide that by 2. Algebra studs out here. I'm hoping you get rid of the 2 first. How do you want to get rid of the 2? Multiply by 2. Yeah, that's what I was thinking too. Everyone's all mesmerized by the rain. Huh? I've never seen rain before. Oh my God. It rains here in Delmar? Are you kidding me?
Why do you hate weather so much? Like for the eclipse, you were like hating on it.
Yeah.
Like,
What do you mean I hate weather? That's a pretty bold statement.
You've been hating on the rain, and now you're hating.
Well, yeah, it's because it's like, oh, everyone's like, oh, look at it. It's raining pretty. Oh, it's loud. Yeah, that's what happens when it hits a roof. Yes, it gets a little loud. Yeah. You guys are acting like you've never seen this before. It's like a phenomenon. It's like the eclipse, right? Everyone get your glasses. Go outside. Let's go check out the rain, everybody.
You should have been a weatherman.
Okay.
And then you can just like...
I'm good, thanks. Okay. Everyone all good on the basics of using a floater angle? Because now we're going to get a little more complex. We're all good? These arcs are in a ratio. I don't really care right now. Here's what I want to do with you. Can we all agree? Oh, even louder. Uh-oh, I guess I got to talk louder now so we're all focused. Angle at, hopefully it won't be flooded when we get out here. When we get out of school. Ooh, might need a raft. Yep. Angle X. Everybody good? This is not central. It's not inscribed, but it is floater. Agreed? So here's what I want to do with you first. Tell me the arcs. Tell me the arcs. We might need one here at the end of school, huh? Tell me the arcs that I need to add together. Now I'm way off topic. Angle X is connected to what arc? Name the arc it's connected to. Here we go. Doyle, what's arc is it connected to? AC. So, all right, I need to know what ABC is so I can add it to what's its vertical angles arc. Zeef. DFG. Good. So I need to know the measures of those 2 arcs to plug it in. Now let's find the arcs. Now let's go back to the numbers are a ratio. We have not done this in a while, but anybody remember back in the day when I like most of you, what we did with numbers in a ratio? We applied what with them, Matt? Put X's with them. So everyone sees arc ABC. It represents by 2 in the ratio. We're not going to put a 2 there. We're going to put 2X there. Yep, we're going to put 2X. CD, we're not going to put a 3 there. We'll put 3X. DFG, we'll put an X. And finally, AG, we'll throw a 4X on that bad boy. But I don't want to plug those in here. I don't want I don't want 2X plus X divided by 2. That's not going to tell me degree measures. I need to actually find the measures. So what can I do with all 4 of these arcs? To find x and substitute it back in. Go ahead, Matt. 360. Why 360? 360 degrees in a circle. Good. On fire today, Matt. It's good to see. So we solve for x. X equals 36. Now, I only need to substitute it in for the 2 arcs we're looking for. If you want to feel warm and happy inside and want to plug it into all 4, fine, go ahead. We don't need all 4, but if you feel like you need to. I plug it into ABC. That arc now is 2 times 36, 72 degrees. And then DFG is just x, so that'll be 36. So now we'll substitute it in to find the floater angle. Halfway in between those two, 54 degrees. Questions? All right, I'm going to let you take a breather right now before we get into this next one. You got to stretch out, stretch out. Got to take a breath or two. Go ahead. Oh boy, that does look intimidating, that diagram. Anybody looking forward to anything later on today?
Leaving this class.
Of course you always do in this class. Yeah, I always look forward to 5th period myself. Yeah. Anything? Nothing coming up later today? Okay. All right, we ready for this? This is what I refer, and you're going to see more and more of these today and tomorrow. This is what I refer to as a king-size circle problem. Kind of like the king-size candy bars. Those things are huge, right? Look at this thing, parts A through E. Parts A through E. I call it a king-size circle problem. This is going to sound strange when I say this, but believe in me. Do not look at what I need you to solve. Okay? A through, I don't care how many letters there are. Don't cross this out on yours. Don't look at that. If you want ultimate success on these king-size circle problems, the first thing you do for me is find all the arc measures first. But it's not being asked. It doesn't matter. I'm telling you, watch what happens. When you find all the arc measures, these problems up above, I don't care if it's A through E, A through Z, are going to become much, much easier than if you try, oh, it wants me to find arc GB and then try to do it. Find all the arc measures first. Please try that out. Find all the arc measures first before you start answering the question. So let's try to do that together. Find all the arc measures. King-size circle problem, find all the arc measures first. Givens, arc AEH. I don't know how you want to label that on your diagram. I do this. 110. AEH. Good. Arc AG, 80 degrees. Oh, there come those numbers in a ratio again, huh? The ratio between AE and EH is 2 to 3. We now know to put X's with them. So on arc AE, throw a 2X. On arc EH, throw a 3X. Find every single arc before we start this problem. Can we start by finding AE and EH? Add them together and set them equal to not 360 this time, but 110. Yep, that's what I was thinking too. 110. Good job, everyone. Not everyone at the same time. So what do we got? 5x equals 110. X equals 22. All right, substitute it back in so I can find those 2 arcs. So arc AE 44 degrees, while EH is 66. All right, there's still 2 arcs that are blank, though. I still want you to find them. How can I find them? They're blank. Ready? This is your first one, so you don't see it. But you're going to start seeing it more and more, and I want you to think about it. AOB. AOB. What is that, ladies and gentlemen? AOB? That's called a what? Oh, diameter. Why is that helpful to us? Because I believe a diameter breaks it up into 2 semicircles. Measuring how many degrees? Oh, so A, E, H, B, all the way around is 180. You know, part of it's 110. So HB, well, how much is left over for good old HB? 70. You found a missing arc. One more arc, GB. 2 semicircles. AGB measures 180. So if I already have 80, that's going to give me 100 degrees over here. Find all the arc measures first. Now, hopefully, ready? Watch how easy this becomes. Now let's tackle parts A through E. Part A, find the measure of GB. Oh, already found it. 100. Nice and easy. Part B, find the measure of arc EA. Oh, already found it. 44. I don't even have to think about this and try to find them separately. They're done already. All right, now we do need to know some rules. EFA. I'm going to sound like a broken record over the next 2 days when I ask you the same questions over and over and over again. EFA, central? Inscribe. It's a floater, isn't it? It's a floater angle. All right, I need to know what 2 arcs I'm adding together then. EFA is connected to what arc measure? EFA connected to what arc measure up here? Whoo, Thomas, what arc measure is it connected to? EFA connected to? 44 degrees. I'm going to add that to its vertical angles arc that it's connected to, which would be how many degrees? So EFA, look at its vertical angle and tell me what the degree measure is, the arc that it's connected to. Ksenia, what do you have? 100. Good. Divide that by 2. That's going to give me a 72 degree angle. I'd also like you put it, once you find it, put it in the diagram as well. All right, so EFA is 72. You never know when you're going to need it next. You never know when you're going to need it next. FEB. Whoa. Before we find FEB, can we also just agree I could also call that GEB, same angle? All right, I just didn't want you guys to look at just starting from F to E to B, but it also includes G. And I say that, is that central? Nope, is it inscribed? Ding, 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 we got an inscribed angle. We got to know our facts. Got to know them. Inscribed angle, we're going to take half an arc now. What arc is connected to FEB? What's the measure of it? Whoo, Josh. FEB is connected to an arc that measures 100. So I'm going to take half 100. 50 degrees. I don't know, I may need it. Watch how crazy these are. We gotta know our stuff for these king size problems. And here's exactly why. Part E. OHD. You look at that thing and you're like, whoa, not central, not inscribed, and not a floater. How am I going to find this? I can't. You can. Hey kids, what's OH up there? What's OH? Oh, that's a radius. Yeah. Look at point H. Can you give me a name for point H? Oh, point of tangency. And I think we've gone over a lot of times when a radius meets a point of tangency, what happens? Done. You don't need a little formula to plug in numbers. It's a fact I got to know. Radius drawn to a point of tangency forms a right angle. All right? So they all may not be central inscribed floaters. I hate to break it to you. That's what makes these tough. You may have to go another circle fact. Questions on this one? Oh, you know, one doesn't make us great. We got to at least try out. No! I don't have time for this. Try out one more. Wish you knew this as much as you knew your circle facts. Only 12, huh? 13? No. 12, 13, 14. There's one more, but not my problem.
Swing. Oh, yeah, swing.
Okay, that's fine. I'll tell you what it is when we're ready. Slide right, left, pinwheel, curl, shatters, wipes, star, drop, five drops, cubes, genie, clock, hook, swing, curtain, flip. You had curtain. Where do you want to flip? Flip, fade, ready?
If it's
Don't start acting like this again.
no, actually no.
Everyone ready? So what do we got? Shatter, drop, and Promethean Man again. Ready? Let's get this over with. Shatter. Shatter. If we just had one more, baby. If we just had one more, what would have happened?
Can you actually show us spin? I've never heard of spin. I don't want to.
You would think I do this all the time, and I still don't know where the page effects turn is. Page effects is view, maybe? Page effects turns. Spin out. There you go, Matt.
What's the one next to it?
That is swing for us. That is swing. All right, back on random. Okay, we ready? Here we go. Another king size circle problem. Notice it's asking me to find two angles and an arc. We don't care. You find all arcs first. Find all arcs first. Read through. Please don't read too quickly either, because you're going to gloss over a huge fact here, and that is AP is bisecting BAC. All right, angle BAC is getting bisected. Which two angles are congruent up here, though? Because I want to put my arc marks on the diagram. Angle BAC getting bisected. What two arcs are congruent? Charlie, up. Back to you. BAC getting bisected by AP. So which two arcs are congruent? What do you have? But it's the angle getting bisected. Angle BAC.
What are you asking?
AP bisects angle BAC. I'm asking what two angles are congruent then?
Okay.
I want to put arc marks on it.
BAE.
Yep, and good. So those two are congruent. Put the arc marks on there because I'll know I may forget about it. And then, yes, I have, take a look. Arcs aren't in a ratio. Angles are in a ratio now. So look at angle ACB, everyone. ACB. I don't want to put a 4 there. We should have a 4x there for us. 4x. Angle CAB. I'm going to put a 3x. Please don't be, I'm going to put 1.5x, 1.5. No, don't do that. Don't bisect it yet. Wait till we know the actual angle measure to bisect it. And then finally, ABC. Not putting a 2 there. We're putting a 2x. All right, help me find all the angle measures so I can solve this problem here, or all the arc measures. Last time we added everything up and set it equal to 360, but this time we don't need 360. What do we need instead? Add them up, set them equal to, Ksenia?
Oh, 360. Wait. 180.
Because it's in a triangle now, right? Everyone, it's in a triangle, so not the 360. It's going to be 180 this time. So we're getting x equals 20. Go ahead, substitute it back in and find those angle measures. Because the angle measures, you may not see it, some of you, the angle measures are going to help us get the arc measures. So let's see, angle B, everyone should have that's 40 degrees, angle B. Angle C, everyone should have 80. And then angle BAC is 60, but it's getting bisected, so I'm going to put 30, 30. All right, I'm going to bisect it right now and go 30, 30. All right, how do those angles help us find the arcs then? What type of angles are all these? Angle C, angle B, and angle BAC. I know they're acute. I meant in the circle. What do I call these angles? Those are what type of angles in the circle? All three of those are what type of angles, Steve? Inscribed. And I know I take half the arc to get them. So going back in reverse, if angle C is an 80-degree inscribed angle, the arc it connects, BA, has to be double it. I now know arc AB is 160. Keep going. Arc AC, double 40, has to be 80. And then how about arc CF and BF? Both of them have to be double the 30s. 60 degrees each. All right. Now we can start answering the question. I feel a lot more confident we'll be successful. Look at it. Look. Hey. Find the measure of angle ABC. Done already. Done. It's 40 degrees. How about angle or arc BF? Done already. Arc BF, 60. The only thing I need your help on is how do I find angle BEP? Okay, take a look. BEP. Central? Central? Nope. Inscribed? Nope, that's a floater, right? That's a floater because the center's O. So I need your help. What two arcs am I going to add up? First arc is, what's the measure of the arc that belongs to BEP? BEP, what arc is connected to it? An arc measure of, Haley?
60.
60, good work. Everyone look at the vertical angle to BEP now. And what arc measure does that connect? 10, Matt? 80, good. And we're going to divide that by 2. Oh, easy with the calcs, right? What's in between 60 and 80? Halfway. 70. Oh, I'm not done though. Not done with this one. Not done. I got one big message to you before you start the assignment. Even the best in here, even the studs in here, the great ones in here will have problems with these king-size circle problems. You may look at an angle and have no idea what type it is, or have no idea how to find it, what the rule is for it. Let's say you totally blanked, had no idea this was a floater angle, BEP. Or maybe you knew it was a floater angle, but forgot the rule. No excuses. No excuses. Hi, I'm a triangle. You know 2 of my angles. Can you find the third? I believe so. That's 70. 180 minus 70, that would be a 110-degree angle. And I'm asking for the angle right next to it. Linear pairs. So I'm telling you, just because you don't know what type of angle it is, or maybe don't have a rule for it, it's no excuse. Find angles around it, maybe 180 degrees in a triangle, maybe linear pairs are supplementary. Never leave an angle blank. You can always find it, even though you may not have a rule for it or have a name for it. Good? Don't give up on these tonight. Do not. You know how to find them. Just start finding angles around it, and eventually you'll get to the angle you need.